So we're going to learn those, or use those identities we just went over on the top of page 276. In example 5, it says applying the trig identities. We're going to start with an angle theta, an acute angle, where we know that the cosine of theta is 8/10. We want to use this information to find the sine of theta and the tangent theta. So first thing we're going to do, we're going to use our first identity, sine squared theta plus cosine squared theta. You guys can find these on the top of page 276. That is equal to 1. Well, the information we're given is the cosine of theta is 8/10. So we're going to substitute that in. Sine squared theta plus 8/10 squared is equal to 1. Subtracting 8/10 squared from both sides, we end up with sine squared theta is equal to 1 minus 8/10 squared, which gives us 36/100. The sine of theta, we're going to take the square root of both sides. The sine of theta is equal to 0.6. Well, now we have the sine and the cosine, and we know that the definition of tangent is opposite over adjacent, or y over x. The tangent of theta is equal to y over x, and we know that to be the sine over the cosine. So we're going to take those two values. Tangent of theta, giving all of the previous information, is going to equal 6/10 over 8/10. Tangent of theta simplifies to 0.75. Please go ahead and try problem 55, and we'll come right back here and look at your solution. So that, check it out, problem 55 is on page 281, and it gives us the following information. The cosecant of theta is equal to 3. We're looking for that angle theta, and we know that the secant of theta is 3 square roots of 2 over 4. Well, the first one they want us to find is A, the sine. We understand that sine theta is 1 over cosine theta, and we know the cosine of theta is 3, so sine theta should equal 1 over 3. Part B is the cosine. We know the cosine is defined as 1 over the secant, and we're given the secant of theta, so 1 over 3 roots of 2 all over 4. That's getting pretty small. Anytime we divide by a fraction, we multiply by the reciprocal. So 4 over 3 roots of 2. We know we can't have that radical in the denominator, so we multiply top and bottom. We get 4 roots of 2 all over 3 times square root of 2 squared is 2 all over 6. This simplifies to 2 roots of 2 over 3. Now the tangent, part C, the tangent of theta is defined as sine over cosine. Over cosine. So we're going to take those values that we just found, the sine being 1/3, the cosine of the same angle being 2 roots of 2 all over 3. And again, we're going to take that numerator and multiply by the reciprocal of the denominator. 3's cancel. We get 1 over 2 roots of 2. Getting rid of the radical in the denominator, we get 1 root of 2 all over 4. The square root of 2 over 4. And the last one, part D, we remember from page 275, we remember that the cofunctions secant and cosecant are complements of each other, and we are given in part D, we're given that the cosecant of theta is 3. Well, if we'll look at this next definition, cosecant and secant are cofunctions. Secant is equal to cosecant of theta. Since cosecant of theta is equal to 3, then the secant of 90 minus theta is also equal to 3. We're going to take a quick look at example 6. It's similar to 5. We have theta being an acute angle such that the tangent of theta is equal to 3, and we're asked to find the cotangent and the secant of that same angle, theta. So for the first part, cotangent theta, we're going to take the definition cotangent theta is equal to 1 over tangent theta, and we just simply replace tangent theta with its equivalent value. Cotangent of theta would be 1 over 3. In part B, we can use our identity. Secant squared theta is equal to 1 plus tangent squared theta. We went over that in 4.3 part 2 on the Canvas recordings. We know that tangent theta is equal to 3. We can replace tangent theta squared, or tangent squared theta, with that same value squared. So we get our simplified version here. Secant squared theta is equal to 1 plus 9. Secant squared is equal to 10. Therefore, secant theta is equal to the square root of 10. Please try exercise number 57, and we'll go over the solution. So problem 57, the directions state that we are given the function value, and we're supposed to use the trig identities to find the indicated trig functions that they're asking us to look for. They give us cosine alpha is equal to 1/3. Well, in looking for secant, we understand secant and cosine to be reciprocals, so we can say secant is 1 over cosine alpha, and we know that 1 over 1/3 would simply yield 3. That's a good one. Part B, we have the identity, the Pythagorean identity, sine squared plus cosine squared equals 1. We can use that here. We're solving for sine, so we can use sine squared alpha plus cosine squared, which is what we have in the original part of the problem, is equal to 1. We get sine squared alpha. We're going to square 1/3 and subtract it from both sides. So 1 minus 1/9 is 8/9. And we get sine squared alpha is equal to 8/9. Taking the square root of both sides, sine alpha is equal to the square root of 8 over 9, which is simply 2 square roots of 2 over 3. Part C, we have cotangent. Cotangent is equivalent to cosine over sine. We have both of those now. We have the cosine 1/3, and we have the sine 2 roots of 2 over 3. So we're going to place those in a fraction. 1/3 over 2 roots of 2 over 3. Multiplying by the reciprocal, we get square root of 2 over 4. Part D says sine of 90 minus alpha. Well, we know that that is a complement to its co-function. Sine and cosine are co-functions. And we know that the sine 90 minus alpha is the same as cosine of alpha, which takes us right back to where we started from at 1/3. So in part 7, we start to get into the fun part of the trig mathematics, and that's using identities to solve these puzzles. In part A, example 7, it gives us this: cosine theta times secant theta is equal to 1. And we want to prove that. The thing that we want to do with all these identities is to work on the more complicated side. So we know that cosine and secant are reciprocals of each other. So we could simply write cosine as 1 over secant and multiply that by secant theta. We change the first one, and then we can simply and easily see that that is indeed equal to 1. So we're going to use this to prove one of the Pythagorean identities. You guys understand two binomials, we can simply FOIL these two expressions. So secant squared times itself is secant squared theta. I'm going to take the product of the inner and the product of the outer, and we can easily see that those two cancel out. Secant, tangent, I'm just trying to save some time and not write those thetas. So we've done outside, inside, and then we have the product of the last two terms, which is our tangent. So we have tangent squared theta equaling 1. We see those middle products canceling out, and we're left with secant squared theta minus tangent squared theta equals 1. And that's one of the Pythagorean theorems, or excuse me, Pythagorean identities that we proved earlier on. So it's always important to start with these identities and work on the most complicated side to reduce it to the simpler side. So we're going to be working on this side of the equation. I can see that the two ratios have different denominators, so I'm going to create one with the same denominator. So sine over cosine, I need it to have a common factor of sine in the denominator. So if I multiply that fraction by sine over sine, excuse me, I get sine squared theta over sine cosine. I'm going to similarly do the thing over here, that which I did. I'm going to multiply this side by cosine over cosine, creating that common denominator. I get sine cosine on the bottom. On the top, I get cosine squared theta. Because the two fractions have the same denominator, I can combine the numerator. I get sine squared theta plus cosine squared theta. You should recognize that as something very, very simple. Sine theta cosine theta. I can reduce that numerator to simple 1. That's 1 over sine cosine. Now I'm going to, I'll just write it out. Sine theta cosine theta. Here's the tricky part. I want to take that fraction and turn it into two fractions. 1 over sine theta times 1 over cosine theta. And we know those simple comparisons. 1 over sine is cosecant theta. Whoops, I missed a C. And 1 over cosine is simply secant theta. So we can see that we ended up with that which we were challenged to come up with in the beginning. So we're going to become very familiar with these trig identities as we work through chapter 4. That being said, we're going to go on to example 8 and 9 and 10 in a separate recording.